Hi, everybody. Thank you for joining today. My name is Greg Chase. I'm the community maestro for Pivotal, and really excited about today's talk. We have Maxim Yukovsky, Director of Engineering and Security at Zettaset, is here to talk to the community about a solution they offer for Greenplum for helping increase security. In addition to that, we have our usual panelists, Ivan Novick, Product Manager for Greenplum, and Scott Kaler, Platform Engineer, who frequently works with a lot of Greenplum customers. So let's go ahead and start off today's talk. Ivan, how do you see security in the priorities of our customers?
Yeah, I mean, with the increase in network capabilities, you can just read the news to see how high profile security is. There's more and more unpredictability and threats to people's systems. And so the priority for securing the system is only increasing rapidly. And from a Greenplum point of view, you know, we've had for a while people pushing and asking for being able to encrypt data both at rest and in motion. And what we decided some time ago was that this is really something that can be done efficiently at the platform layer. And it would be more efficient to do it at the platform layer than to try and bake into the logic of the database, the encryption. So we were really fortunate and happy to see Zettaset's solution after talking to quite a number of vendors to see their approach and how seamlessly it integrates with a database product, because it's really completely transparent to us and allows them to encrypt the disk and the network. So really happy to see it and looking forward to hearing the talk today. And yeah, go ahead, Greg.
Well, and I think you had a question for Scott.
Yeah,
related to this.
Scott, after having run it through some trials, you know, what was your experience with it?
Well, I was really impressed with it. I guess for years we've talked about kind of the main focus for securing Greenplum was that a lot of the nodes can sit behind on a separate network. And that's been pretty good security for everybody. But as we move into this new age, cloud virtualization, all that kind of stuff, and there's more security, being able to encrypt the talk between the servers and just data at rest encryption, being able to do that is becoming more and more important. Being able, when I use this, just installing the software was really easy. That was one part I really liked about it. I also liked the part that deploying to more nodes as I grew the cluster out was fairly easy. I like that it was software, not baked into the database, because what that means for me is if I'm adding ETL servers to my cluster or something else, it's not just my Greenplum database that can be covered by this. I can expand outside of all the things that are needed to support a Greenplum database. You know, like maybe my monitoring server, maybe it's my ETL piece, all that stuff can use this same encryption also. So, I mean, I was pretty impressed by the package. I think it's good software. So, yep. So I'll kick it back to you guys.
Well, got me excited to hear about it. So, Maxim, why don't you go ahead and introduce yourself and tell us what you've brought us to share.
All right, thank you. Yeah, thank you for having me. My name is Maxim Yukovsky. I'm the Director of Engineering here at Zettaset. We're based in Mountain View, California, and our team comprises of a number of people who have quite a few years of security and encryption experience and background. Actually, a number of us work together for over 10 years now, and we work in companies such as Ingria Networks that was later acquired by SafeNet. And if you're familiar with the SafeNet key managers and Luna appliances, the SafeNet key manager is actually the one that our team built. So we definitely bring a lot of security and encryption experience into the enterprise. And although we started as in this company, we started as quote unquote Hadoop oriented company, we quickly realized that the Hadoop marketplace is really not picking up as quickly as we would have hoped. So unfortunately, that wasn't coming up too quickly. And we quickly pivoted the company and reoriented ourselves more towards our main area of expertise, which is securing and encrypting data, but also with the new trends of securing and encrypting data in highly distributed systems and in the cloud. So today we're going to talk about the entire product portfolio that we offer that extends beyond the product that Greenplum is using, but we will focus definitely on the products which are currently relevant to Greenplum. All right, so let me share my screen. I've prepared a small PowerPoint slide deck. So quickly, the agenda is I'm going to introduce Zettaset, which I sort of done a little bit already. We're going to look at what problems our solutions address. What are we aiming to solve in the enterprise? I'm going to go over Zettaset Encryption Suite. As I mentioned, it's going to cover the products which Greenplum is using and also the other products that we're using, that we're offering for various other environments. We're going to talk about key management and key administration. Why is it really critical and really important with encryption? And then we're going to dive into the Zettaset BD Encrypt product, which is the one that Greenplum database is using. And we're going to take a look at the architecture of both data at rest and data in motion solutions. So if the agenda sounds good, we'll go right in there. So as I mentioned, we really started as a big data management company here. We work with Hadoop. We attempted to provide a software-based solution which would allow companies to very easily roll out complex big data Hadoop-based environments. And that was at the time, that was several years ago, that was at the time when installing a Hadoop cluster was really a complicated matter and it involved a lot of manual steps. So we were able to automate all of that. And as we introduced new features, we started, of course, contributing, our core knowledge base, which is security and encryption. And we started securing Hadoop beyond the level of security that was offered in the community. As we were doing that, we were also realizing that the Hadoop marketplace and the Hadoop market really is not picking up as quickly as we had hoped. There were a lot of talk about Hadoop deployments, but there were not a whole lot of real production deployments. Most of it was small clusters, people kicking the tires and all this. So we pivoted the company. We started looking at what would it take to really secure an enterprise distributed environment, because there are some unique challenges in securing a distributed environment. Legacy vendors, some of our competitors, would have you believe that you can use kind of a legacy solutions, file system encryption, basic network encryption. You can just drop it into a distributed environment and kind of call it a day. If you look closer, it's not really the case. I'm going to talk about this a little more as we go forward. So we looked at what it would take to secure a distributed environment. We looked at what it would take to secure a cloud. What are the challenges in the cloud? And the biggest one is that customers who would be willing to put their data in the cloud, one of their main hurdles with respect to security is that they don't trust the cloud provider, not only with their unencrypted data, but also if the data is encrypted, they don't trust the cloud provider with their keys. So, and also, of course, given our Hadoop background, one of our encryption solutions was specifically targeted to provide very granular file level encryption for Hadoop. And then we're basically taking this feature set and adapting it into the cloud environments. Our approach is purely software-based. That's not to say that we don't interoperate with security and encryption hardware, but we don't require you or our customers or your customers to buy into encryption and key management hardware. We're completely self-contained, and we can be used with other security and encryption hardware, but this is not a requirement. So our approach is purely software-based. So the shortcomings in the existing technology is that the scaling up and scaling down is definitely complex, and the distributed clusters, nodes come and go pretty much on a daily basis. Lack of automation, we've seen a number of times that when an encryption solution is deployed in an environment, suddenly the administrators, be that system administrators, be that cluster administrators, they have to introduce themselves to a number of concepts that relate to encryption, which security administrators are familiar with, but the system administrators don't necessarily need to be. So suddenly system administrators need to know about, the zone keys, the wrapping keys, the data keys, the file keys, and all those wonderful, SSL certificates. So this is all, this is the language we talk here, but we don't necessarily introduce this language or push this concept onto security admins. So we're trying to be as transparent as possible. Scalability and performance, you guys can speak to that as much as we can. We were able to design our solution to achieve minimal performance degradation. And over the years, as we were doing different encryption solutions, over the years, one of the biggest hurdles was to explain to the enterprise that, first of all, encryption is required because the cost of the data breach is enormous. And second of all, encryption is not free. The most frequent question that I hear is, well, how come you're introducing performance penalties as part of encryption? Well, because data transformation, and as any data transformation, is not free. But we definitely went to great strides to take control of performance and make sure that performance is manageable. And also, if you look at competing solutions, really, if you don't have a homogeneous environment that pretty much nobody has, you will need to employ different solutions, possibly from different vendors, and then the management becomes quite complicated. And the implementations, again, a lot of our competitors would have you believe that integrating on the application level is really, really nice because, for example, in Greenplum, you could integrate right inside the database engine because you own the database source code, and that's the optimal. However, that introduces quite a few headaches with respect to maintenance, security patching, and just in general, application level integration may be the most beneficial, but it's also the hardest to do and the hardest to maintain going forward. That's why we're trying to be as transparent as possible. And this slide really talks a little bit more about what it would take to take an encryption solution into the cloud. I'm not going to spend too much time on it. The core message here is that the biggest concern when putting your data in the cloud is who controls your keys. Take a look at AWS S3, for example. They have government cloud, what they call the EC2. They can deploy dedicated hardware security modules for you, and then at that point, the price point has just become, unmanageable. And also, even the dedicated hardware security appliances, they're still deployed in Amazon web centers, in Amazon data centers, and they still have physical access to the devices. They may not have passwords, but it's a matter of who owns the device. So customers are really, especially government customers, they're really uncomfortable with having their keys anywhere but on their premises. So with our software solution, we're able to offer complete key management and control to enterprises who want to put their data in the cloud at a fraction of the cost of hardware key managers. We have 3 products that comprise our data encryption suite. The first product, and then that's the product that Greenplum is using, is what we call Big Data Encrypt, and it's a high-performance volume-level encryption for Hadoop, NoSQL, and any other relational data store pretty much that runs on top of a Linux partition. The goal here is encrypt everything, do it transparently, and achieve the highest level of performance possible. Big Data Encrypt Plus, on the other hand, is going kind of up the encryption stack, and it's more granular. It's a file-level encryption solution that is specifically designed for distributed systems, for HDFS, and we're taking most of the features and are adapting it to the Amazon S3 file system, and in general to cloud file systems. It's just that S3 cloud file system happened to be the first file system where we're looking to adapt to in the cloud. So I'm not going to spend time on Big Data Encrypt Plus or HDFS or Hadoop or S3. Just wanted to mention that this is the 3 products that we have. But today presentation is going to focus on Big Data Encrypt. Relative positioning with respect to encryption stack, where you can apply encryption. Of course, starting at the bottom with the self-encrypting drives, you can apply the encryption there. Of course, key management becomes a problem because, how do you manage keys? Do you have a key for a drive? Do you have a key manager that manages keys for the drives, and it quickly becomes really complicated. Disk partition is basically transparently encrypting one or more partitions on the device. And that's where Big Data Encrypt operates. That's what makes it transparent to databases such as Pivotal Greenplum. Big Data Encrypt Plus, on the other hand, operates on the files and directories level. So it basically runs on top of the HDFS file system and or on top of S3. Of course, you can apply transparent application via Crypt APIs level higher on the database level. So you could have modified Greenplum source code and call Crypt APIs, but then there's going to be a substantial maintenance headache with that. And of course, application level integration is by far the hardest because that basically means you modify not only the database source code, but also the application source code to encrypt and decrypt certain fields if they're accessed by the application. So as you go up the stack, there could be some additional benefits, but definitely the complexity increases and the level of maintenance increases. And the level of transparency decreases quite a bit if you get closer to the application level integration. So Big Data Encrypt is on the partition level. Big Data Encrypt Plus is on the file system level, currently for HDFS and targeted to S3. And both of those components share a common component that we call the Zettaset Key Manager. And we're going to talk more about it in that slide. So why key management is so important? It's kind of, I would say, in my over 14 years of experience with data encryption, is key management is the hardest aspect of encryption, and it's the most overlooked one. So if we start talking about key management, typically people would say, well, key management is not that complicated. All key management really is generate a key, here's a key, store a key, and now I want to encrypt or decrypt something with this key. Please give me back that key. Now, the challenges that it introduces is that the application and the application administrators now need to know about keys and key hierarchies, and it's way more than just one key or one key type. So scaling, for example, if you're encrypting a cluster of machines and you're encrypting a number of partitions on every machine, you would be using, let's say, at least one key per partition. As the number of nodes grows, the number of keys grow, and then the system administrator and the security admin needs to keep track of which keys apply to which machine, how the keys are stored, how the keys are retrieved. And so there's a whole more to key management than just storing and retrieving keys. There is this whole concept that we call key administration, which is basically what happens in the secure encryption system when users and applications start basically performing their daily activities. What happens when the files are created? What happens when the new nodes are added? What happens when the node is removed from a cluster? How do you handle all this activity in a transparent way, but also consider all the security implications? My favorite example is how do you take a node and securely remove it from the cluster? Let's say you're taking a node down for maintenance, or you decommission the node completely because of a hardware failure. If the node is up and running, it's very easy for the system administrator, if the node is on the network and reachable, very easy for the sysadmin to go and wipe out the data, the sensitive information. However, if the node is off, there's no way to go and wipe out the data. So as a malicious user, I can take a node, and we all know the biggest threat comes from within the enterprise. It's not really the outside threat. So I can take the node from the data center, go home, plug it into the network, connect my VPN, and suddenly I'm decrypting sensitive corporate data. In our solution, what happens is that if admin wants to decommission the node, they run a simple command that I'm going to show later in this presentation. And from that point on, the node certificate that gets issued to a node at the installation time, the node certificate gets revoked. So the key manager is no longer going to issue encryption and decryption keys to that node. So even if the node were to power up and attempt to join the cluster, at the time when it will attempt to contact the key manager to mount its encrypted partition, the key manager is going to say, I'm sorry, but you've been removed from the cluster. I can no longer issue the certificates. And this will prevent the node from mounting the encryption file system and consequently prevented from accessing the encrypted data. So that's one of the big issues that we see with legacy implementations that basically just put the file encryption under a database or under a solution kind of called today. Although we run on the partition level, we're very much aware of the fact that we're running in a multi-node distributed environment. Also, we're aware that we're operating with large data sets and large data volumes. That's why we're able to offer key rotation with a unique key hierarchy that we have. We're able to offer key rotation without re-encryption of the entire data set. So this slide basically gives maybe a 10,000 feet view of big data in Greek. The flagship features, of course, advanced and automated key management. I mean, I think Scott can speak to that, that when he was adding or removing the nodes, he did not need to create any keys or perform any crypto activities. He basically would modify the installer script or the installer configuration file and just say, I would like to add this node, and this is the partitions I want encrypted. And we would go and generate the encryption keys, we'll generate the node certificates, and we assign the node certificates to the nodes and do all this whole key management so on and thence. And if the node is removed, then this is handled pretty much automatically by a script. Data at rest and data in motion is both used by Greenplum. Performance for data at rest is very low. Our measurements show about 3% performance impact. I think on Greenplum side, you're getting higher numbers, but I think they're still very favorable, as I've heard. All the data on the partition or on the set of partitions is encrypted. Again, as Scott mentioned, you can encrypt partitions that store Greenplum data. You can also encrypt partitions that store ETL data. You can quickly expand encryption to any other partitions on the file system that you would like.
Maxim, let me interrupt one point. The cool thing about the 3% and 7% penalty is that in an MPP system, we're scale out, right? So even though you have a fixed overhead per node, as we scale more nodes, you're getting more IO, right? So we can, if let's say, for example, we're getting 1 gigabyte a second of IO, and that goes down to 950. But if we add two, we've got 1900, right? It just keeps increasing as you add the node. So it's a fixed penalty per node, but it doesn't impact the ability to scale out. Does that make sense?
Right. Absolutely, yes, and that's a very good point. I kind of touched upon it in the previous slide to say that scalability is definitely a big issue in the distributed environment, and we were able to address that. And it's good to hear that you actually seen that in real world environment. Yeah, so as Scott just messaged, I think, to everybody that adding nodes is pretty easy. Removing the nodes is equally as easy and equally as transparent. And I'm going to go into a little bit more details about that. Data in motion encryption, again, reasonably small impact. I believe on Greenplum, again, it's higher than 7%, but it's also, some of it is due to the network aggregation that Greenplum database is doing, but I think the performance numbers are still favorable. And all the cluster communications on the interface are secured. Not just communication between Greenplum components, basically whatever is communicated on the interface is going to be encrypted and secure, and nodes can be added and removed with the same level of simplicity. Deployment is pretty simple. We have command line installer that supports distributed installation. It's based on Ansible. So because it's a command line installer, Ansible and shell script based, it could be easily incorporated in the complex workflows. The requirements are reasonably uncomplicated. It requires SSH trust between the node configuration. And this slide, the next slide, is going to show the architecture of the installer, which is, we have the installer host, which is basically the host that drives the installation. And on the installer host, we have what we call the inventory file that basically says, I would like to deploy the product on this set of nodes. And it also includes additional configuration to say, on this node, I want to encrypt partitions 1, 2, and 3. On the node 2, I want to encrypt partitions SDA1 and SDC3, for example. And once the SSH trust is established and the inventory is configured, you basically run a simple installer command, and it goes and deploys software on your nodes. And it mounts the encryption partitions for you. It can optionally format a file system and present it in as the ext3, ext4, or other file system. From that point on, your file system is encrypted. You can copy data onto the encrypted file system. Also, we support encryption in place. So if you already have if you already have data on some of the partitions, then we can unmount those partitions, migrate them, and then mount them back. The feature set is pretty substantial. So it's a high-performance partition-level encryption. We have the KMAC compliant key manager with passive backup. The KMAC compliance and the next point, PKCS11 compliance, means that we do include the key manager, and we do include the software-based HSM, what we call the software security module with our solution. But we allow you to integrate very, very easily with enterprise-grade key managers. If your customer basically says, I already have a number of SafeNet key secure appliances, I would like to integrate with them. It's as simple as flipping a switch in the installer and saying, instead of Zettaset key manager, I want to use the SafeNet key manager or HP key manager. We've gone through integration testing for KMIP key managers and PKCS11 HSMs with SafeNet, Thales, HP Security, number of encryption and security vendors. Also, the key manager is currently offered with passive backup, meaning if you want to fail over the key manager, you have to run some scripts to migrate the key database from master to the backup. However, we have our patented high availability. We are almost done with integrating this into the with the key manager. So in the future release, which is coming out pretty soon, we will have our key manager highly available, and the high availability is going to be completely transparent. Failover will be handled automatically. So it's not something that we have today, but it's something that we have, I expect, definitely before the end of the year, most likely sooner. The reason we're able to achieve that level of performance is that we're encrypting in the kernel. And the partition key is obtained at boot time and is kept in the kernel. So when the node boots up, it contacts the key manager and presents its certificate, and that's the certificate that gets revoked if the node is removed from the cluster. So command line installer that we offer support distributed installation, very easy to add nodes, and we're able to preserve data and encrypt in place. And we can be formatted as any file system. So the architecture, and I'm not going to spend too much time on it, but suffice it to say that we run the kernel module inside the kernel space just below the file system. However, we integrate with the key manager and present the node certificate to the key manager when it's necessary. And key manager consults the certificate authority to verify that the certificate is still valid. And key manager contacts the HSMs to obtain the master encryption key to be able to decrypt the node key and present it to the node. So it's pretty elegant architected solution. It's very lightweight, completely software-based. And so for the database such as Greenplum that runs on top of the Linux file system, the solution is completely transparent.
Maxim, can we clarify, the new default in Red Hat is XFS, and Greenplum is very XFS friendly. Is there any issue with XFS?
No, not really, because we're presenting our own encrypted device, and we can, I'll have to go back and check if we tested it with XFS. I think we might have actually verified the compatibility, but it's going to be as simple as changing a few flags on the installer and basically saying, I want the file system to be formatted with XFS. And I think Scott just confirmed that it works with XFS.
Okay, just as an FYI, we're heavily XFS based.
Okay, yeah, we're not really file system dependent. We present our own device that can be formatted with as any other file system.
Okay.
Yeah, so the installation steps are very easy. You get a license file from us that basically gives you an ability to deploy on n number of nodes, establish SSH trust, temporarily stop the firewall, install basic set of prerequisites, and then update the inventory file to say which nodes to install on, which partition to encrypt, or which set of partitions to encrypt, specify some parameters for the hardware security module and internal CA, and then run the installer. That's pretty much the ease of deployment. And after installation, you could see those partitions that are marked as Encrypt2 and Encrypt3. You may see them differently, named differently in your environment, and they're basically going to be mounted at a certain mount point, and they're going to be encrypted transparently. So a small test case can be used to confirm that the data is encrypted, and the data will be encrypted for sure. Data in motion encryption secures all cluster communications on the interface. So whether it's a Greenplum database or other components talking over the interface, same thing. It can be applied to any network interface. It basically runs inside the TCP/IP stack. Again, integrates with KMIP compliant key manager and PKCS compliant software HSM. Also integrates with any other key managers and HSMs that are PKCS 11 compliant and KMIP compliant. And it's based on the standard Linux tool. So we didn't reinvent the TCP/IP encryption stack. We just took the tools and kind of married them together and introduced the same concept of node certificates, authentication to the key managers, and HSM. So every data packet goes through pretty much, if you're familiar with IPsec, it goes through the IPsec stack, and then we integrate with the key exchange daemon to manage the node certificates and to integrate with our key management. So we took a set of disconnected tools and glued them together with our unique glue layer and introduced enterprise-grade key manager in there. And installations is equally easy. Again, get the license from Zettaset, pretty much the same steps, except instead of running install ZTS dar, you run install ZTS dim. And instead of specifying which partitions you want to encrypt, you specify which network interfaces you want to encrypt on. And with TCP/IP dump, I mean, probably not going to look at it very closely. Go ahead.
One question. You said stop the firewall. Do you run network encryption and then just keep the firewall off, or do you keep a firewall running and do encryption?
So it's up to you. We need to stop the firewall for Ansible to work. So it's more of an installation time requirement.
So you still run with the firewall enabled in production?
We can, yeah. I mean, in general, we're a security company, so we can't tell you, please disable your firewall. That just wouldn't sound good.
Okay.
TCP/IP dump is the tool that we use to basically verify that the file, that the network traffic gets encrypted. You could quickly assess it by looking at the clear text on the left and ciphertext on the right. You can treat it, it's been a while since I read heads dumps, but I can say on the right that there's some clear text flying on there on the wire, and there's no clear text on the right side. Removing nodes from a cluster, the node certificates are revoked, and the key manager no longer issues the keys. So we have a couple of scripts which basically say what are all the hosts that are currently authenticated, and the key manager is going to issue the certificates to, and it's going to list you all the hosts, and you can basically say, now I want to revoke a given host. And so the host will continue to operate because the partition decryption key is already in the kernel, but as soon as the host reboots, or in case of the network encryption attempt to reestablish a connection, it will actually drop active connections for data in motion, and data at rest, the host will not be able to authenticate after reboot. And this is all the technical details. We have more time, but I really want to spend as much time as I can answering questions or giving additional information that you find is relevant to you. So that's all I had for the technical presentation.
So there was one question that I got privately from the audience, which was about running this on the EMC data computing appliance. And I know in the past we had done some ad hoc solutions, but the product manager of the Dell data computing appliance is aware of this technology, and I think they would be willing to work with us and either pre-approve it or integrate it. So I don't think that should be a blocker if anybody's interested in running it on the appliance.
Right. I don't think that should be a blocker. We should look at the architecture of the appliance and what proprietary software they're running. We've had experience with EMC 1FS.
No,
and,
it runs XFS locally.
Okay, if we're doing XFS locally, then that shouldn't be a problem. We should still look at architecture, because EMC has been known to disable kernel modules in their kernel stack, and we rely on the kernel module. So that's something that we need to look at.
Okay.
Okay, Maxim, I had a question.
And actually, Scott, if I can just interject really quick with a kind of a point of order for everybody who's been hanging on up to now. If you have questions, if you've not already discovered it, there is a chat button at the bottom of your screen. If you go down and look there, you'll see the chat scroll that some of us have been chatting back and forth on. If you would like to submit a question for the panel or for Maxim, please enter your question there. And assuming someone doesn't already answer it in chat, we will address it as we have a chance here. So with that, Scott, please start with your first question.
Yeah, okay, so a lot of times in the Greenplum cluster, we have multiple interfaces, one that does the internal network and one potentially that's like an external network. It's in my testing, it is possible to encrypt and tunnel one interface and not the other one, correct?
It's possible to encrypt any number of interfaces. However, if you're encrypting an external interface, it's basically two-way authentication. You know, the sender needs to present a certificate to the receiver. So if you're encrypting clients, you will need to configure our software on all the client nodes. So encrypting external interface takes slightly more work, but it's still doable.
Okay, so like in our situation, what we could potentially do is use our interconnect, which is where all the nodes talk to each other. We could encrypt that interface. And then if our data loading was over SSL, we could leave the external interface using SSL encryption to push everything in. So depending upon what our needs are, we could decide which interfaces we want to encrypt or leave unencrypted, right?
That's right. Yeah, we're pretty flexible in that way, yes.
Cool.
All right, I'm not seeing any questions in chat at this moment.
It's a solution that presents itself with no questions required.
Well, there was a lot of technology that was, Maxim had to run through really fast. I wonder if the architecture slide might be worth revisiting really quick. And then afterwards, I see Sandeep has actually put a question in there.
There's actually a question in there. Can I encrypt data for a particular column?
So
if you're looking to encrypt a column at a time, then that's not the, we're not offering that feature. We're really encrypting everything on the partition and by extension, everything on the database. You can depending on the architecture, if Greenplum allows, let's say, put in a certain table in a certain set of data files and then put in a certain set of data files on a certain partition, you could do it this way. I would not suggest doing that.
That's not the intention here.
Right.
Good question, Sandeep. It's frequently asked, but I think the intention here is that you're just going to encrypt everything, right? So why should we not encrypt everything, right? You're going to create security across the whole system, and the benefit for doing it this way is that we reduce the overhead from putting intra-database logic, right? So it's just completely transparent. We just encrypt the whole drive. It's not if you want to do it at a particular column, then you do something like a PG crypto where you call a user.find function. We also have some other partners that approach it from a different perspective. I won't mention on this call, but there's some other partners where they're doing more of a kind of a logical encryption, but it has a different set of benefits and trade-offs.
I think one thing that would actually be useful to walk through again, I know Maxim did cover it, but especially since you guys don't just do encryption, you also do things like access control and authentication. If you could sort of walk through again how getting permission to decrypt the database, so to speak, with keys fits into things like authentication and access control. Because, and I'd be curious, like, how does this tie into the authentication and access control that Greenplum integrates with? Because this becomes a really interesting way to not only be able to decrypt access to the data, but this is where you get into things like who can do what to tables and et cetera.
So Greg, let me first, before Maxim jumps on it, remember this solution, what it's doing is preventing hackers and attackers who are they don't have necessarily access internally to the database, but they're hacking in through the backend. They're coming at the disk or at the network to intercept and to get the information, right? So it's encrypting it so that if you go onto the physical machine and try and read the files or the network, you have no idea what's going on. It's not encrypting the data internally, so it really doesn't matter from a user perspective, right? It's not doing a logical interception of which user, what's encrypted, what's not encrypted. It's creating a blanket layer of security for hackers and attackers who want to go around the database to go underneath and bypass.
Exactly. Yes. Yep. The extension of this, there's a follow-up question on the previous question as well. What is the performance impact when we decrypt the data, when querying the data, if encrypting everything on the database? So from my previous experience, a number of previous companies such as SafeNet and Ingrian, I can tell you that deploying column-level encryption will result in significantly higher performance overhead than encrypting everything in the database. The reason is, once you encrypt the values of the column, on the database level, your searches become really, really slow. Unless you integrate inside the database engine and you basically encrypt the search criteria and start looking for whatever the search criteria is in the encrypted form, the performance overhead is going to be enormous. So that's how encrypting everything is really going to give you better performance numbers than selective encryption.
And just to be clear, right, if you have a user, let's say you have a super user, right, and they can log into the database and they query the database, nothing is going to be encrypted. They're going to see all the actual, correct me if I'm wrong, but they're going to see all the actual data. What we're really protecting is for hackers who don't have a password to the database, who are trying to bypass and go directly to the OS.
Exactly. Yep. Yeah, so we're not trying to mimic. Go ahead.
If somebody were to walk out of the building with the hard drive from one of these servers, they wouldn't have anything useful on there, any information that they could parse, because it would be encrypted.
Right, and these are government standards, mandated requirements, and not just government, but practical security requirements that, because what you're saying is with physical access, you could bypass all of the well-intentioned security principles of the database, right? And this is preventing physical access from being a risk.
Yep. And by the way, very good point, Scott, that this product really addresses a number of compliance requirements as well. We actually unofficially call it a compliance product because it allows you to achieve PCI compliance and HIPAA compliance, because all of those require encrypting data at rest.
And FIPS, FIPS.
I'm sorry?
FIPS, F-I-P-S. FIPS
I still didn't hear that.
How about FIPS compliance, F-I-P-S?
Oh, no, I certainly know what FIPS is. So FIPS, our solution can work with FIPS compliant key managers and HSMs. Our solution itself does not have a level of FIPS compliance. And because it's a pure software solution, there's only a certain level of FIPS compliance it can possibly achieve, right? Because certain level of FIPS, I think FIPS starting with FIPS level 2 require tamper evidence, which is basically proof that somebody's tampered with an appliance. And FIPS level 3 and higher requires tamper resistance, which is once you open a box with keys, the keys have to be physically destroyed. There's like FIPS level 3 appliances, they usually have like little capsules of acid that once you open a box, it spills and basically destroys the chip on which the keys are stored. The way we would achieve, or at least run in a FIPS compliant environment, is by running and integrating with the FIPS compliant key management, and HSM appliances, and also possibly run our software key manager inside the FIPS appliance. That would be the way for customers that are really requiring the FIPS compliance.
Okay.
So I want to get back to the earlier question, which is authentication and how the keys are obtained and how the partitions are unlocked. Basically, a little bit more architectural overview of this slide as far as the top right portion. So what happens is that, let's say you have a cluster of nodes, and one of the nodes is booting up. As part of the traditional node boot up sequence, it will try to mount all the partitions on the node. So when the mount request is issued, it's going to go through the kernel stack and will get to the file system stack, and it will isolate the device driver and the kernel module that's responsible for this device. And the kernel module is going to be activated. And the kernel module is going to say, okay, fine, let me try to mount this partition. But before doing that, I have this sequence of requests I need to issue to the key manager in order to obtain the key to decrypt the partition. So at this time, we're going to reach out to the key manager, and we're going to present a certificate that was issued to the node at the installation time. This certificate is basically going to say, I am node 1. This is my certificate. It's signed by your certificate authority. And the key manager is going to take the certificate, look at it, and say, okay, well, the certificate is still valid. It doesn't appear in my certificate revocation list, so the node is still good. The certificate is not expired. So let me look up, based on the information on the certificate, let me look up what's your encryption key. So it finds the encryption key, and the encryption key in the key manager is stored in the encrypted form itself. So the key manager is basically going to say, let me go to the hardware security module and ask it to decrypt the encryption key. We call it the wrapping key. So basically, it's a typical key hierarchy where hardware security modules are basically small key managers which store and manage small number of keys, but they never give out the keys. They only store keys, or they can perform crypto operations with those keys. So we present the encrypted node key to the HSM. The HSM uses its master key to decrypt the node key, sends back the decrypted node key, and because the node has been authenticated, we securely send it back down to the driver, down to the DEncrypt kernel module, and it stores in the kernel. And from that point on, the partition is mounted, and everything that's running on the encrypted on top of the encrypted partition can basically read and write data transparently. So Greenplum database can basically read and write data without really being concerned that the data is being transparently encrypted and decrypted. Of course, the benefit of it is complete transparency and high performance. The implication is that there is really no per user distinction. The authentication is done on the node level, and whoever can authenticate to the nodes and have permissions to access files on the Linux partition can access the encrypted information as well.
Maxim, lots of good information here. I know we could easily go another hour just talking about the details as well as the implications of this. Unfortunately, we're coming up to the end of our time here. I was wondering, for Greenplum users that are interested to try out your solution, where can they get it, and how do you recommend they get started?
For users to get started, it's very easy. They basically will receive an installation package and a license file from us. This will allow them to deploy on N nodes. You know, the license file can say you can deploy on, let's say, 5 nodes or 10 nodes or 3 nodes, and they can install it and run through basically the same installation steps that I believe Scott has run through, and get the environment deployed. And it takes really, you know, depending on your data set, if you want to encrypt an environment that already contains existing data, then of course it would take longer than encrypting empty partitions.
And is this are these downloads that you can get off of Zettaset.com?
Those are not available. Well, they're not directly available on Zettaset.com. They will go through our I think, sales management team. We will basically, you'll tell us how many nodes you need for and we'll issue you the license file and give you a link to the package.
So who should they contact in order to move forward?
You can contact me or Gerald, actually, or Tom Waller. Any one of us is going to be able to help you.
All right.
And we have dedicated people here who can help you guys with additional installation questions and basically spend some time with you on the WebEx and help you install this. But it's pretty transparent. The big thing is getting the prerequisites all together. And I think by now Scott knows as much as all of us with respect to what it takes to install the software.
Hey,
but we're definitely there to help.
Yeah, Maxim, I forgot to mention there's one other piece of your job title that I meant to ask you about. It says you're a security coach. Can you explain that?
So this is really comes from my experience in, how to say this, trying to increase adoption of security in the enterprises. I've had, not just myself, but our senior security architect, Eric Murray, we collectively have been trying to basically educate people and explain to customers and enterprises that security is really should not be reactive. You should not wait for the data breach to occur before starting to encrypt your data. You should really be proactive with security. You should deploy security. You should bake it in as part of your solution. You should measure performance and understand that security is not free. So that's my kind of, I don't know, after hours activity to try to increase adoption of encryption and security. And it's really nice to see that you guys are taking proactive steps because I've seen security being reactive largely.
Thank you, Maxim, for a lot of really great information. So it sounds like not only can they try out your software by contacting you guys, and I'll just assume there's a contact form at zettaset.com, but actually you and your colleagues even are willing to come out and do a little evangelism and education on the importance of security at the enterprise level.
We'll all help make it work.
Yeah.
Out to anybody you know.
Okay. Last question, Maxim. I know I'm going to get requests for your slides. Will you be able to send me a link to your slides on a SlideShare, or alternatively, you can send me your slides later and I can arrange to have them posted?
Yeah. Okay. Absolutely.
All right. So thank you, everyone. This concludes today's Greenplum Chat Live. We'll post this recording in a couple of days. So thank you all for joining and have a great rest of the week.